Okay, so let's say we actually notice that there are differences in our factor means. The question is, well, why do they actually differ from one another? And it could really be one of two things. And really a combination of both. The first is that it could be just be random chance, randomness or chance. Recall from chapter 1, we discussed sampling error. So whenever we take samples, any sample to sample, there's always going to be differences. They're never going to be identical. And so there's going to be differences from sample to sample. So some samples might produce a difference, others might not. But the other, and the one that what we're really trying to test for is that whether the factor effect on there's a factor effect on the population means. And so whenever we go through this ANOVA process, we're really going to analyze the variance of the data. Hence, we call it analysis of variance, because the variability in the sample depends on variability in the population. So let's just take another look at our box plot. So in terms of variability, we might say, okay, Asia is all the way up here compared to, let's say, North America, which is just down here. So we can see that these are pretty different from one another. They kind of seem to be non-overlapping, although we do see this one outlier up here for North America. So in this case, we might say, well, okay, well, the continent does seem to have an effect. Asia's box plot is all the way up here. The US or the North Americas is all the way down here. They don't seem to be overlapping, and so we might say that continent, yes, does have an effect on traffic congestion. However, it could also just be due to variability within the continent. So let's just take a look. We might say, all right, well, Europe is overlapping with North America quite a bit, right? Those box plots are overlapping substantially. However, the variance within each of those continents is very different. Europe's is tiny, it's just right here. But the US's is like twice as much. The variability is much larger in North America compared to Europe. And so we might not find a difference here because while the means do seem to be a little bit different, the variability within the US is so much bigger than the variability within Europe that we might actually not notice any difference between the two continents whenever we actually go and perform a formal statistical test. And that's just because the variability within these different continents are very different from one another. We might even think South America, this almost looks, let's see, right skewed, right? Mean, or no, I'm sorry, left skewed, right? The mean is lower than the median. But Asia is right skewed because the mean is bigger than the median. And so, again, we might find a difference between them, but the variability within these two populations are very different. One's left skewed, one is right skewed. Comparing Europe and North America, North America's variability is double Europe's variability. And so that's what we're looking at with ANOVA. Not just the differences in the means, but also our variability across continents, also variability within the continent. We have to take into account how much variability each continent actually has. So we can't just look at the variability across continents, we're also going to be looking at the variability within. So that's a really key concept for ANOVA. So to kind of partition this variability, we need to use something called sum of squares. So sum of squares. So we're going to have our total variation in the data. So the entire data set, all four continents combined, that's the total variation in the data set. And it's going to be due to two things. One is due to the factor, so variation due to factor. And the second, so plus variation due to random error. And we're going to use something called sum of squares. So we're going to have sum of squares total, which we'll abbreviate as SST. It's going to be equal to the sum of squares among groups. We're going to call that SSA, plus sum of squares within group, so plus SSW. So SST, so the total variation in the data, will be differences across groups plus differences within groups. And so if difference in means is due to the factor effect, that thing that we're interested in with ANOVA, then most of the variation will come from among groups or between groups. So we might think, so among or between. I'm going to use those words interchangeably. But if the difference in means is due to some random chance, then most of the variation will come from within groups. So let's go ahead and explore the equations we have for the sum of squares. Okay, so SST, total variation. Let's just look at all of this. So X bar bar is the overall average in the entire data set. Xij is just one single observation. It's the ith observation from the jth group of the factor. So we're going to look at the difference, the squared difference between any individual observation and the overall mean in the data set. We're going to do that for every observation in the data set. So we're going to do that for every observation in every group. So I equals 1 to nj. So j is representing the jth group. Recall there are C groups. So we're adding up all the total variation in the data set. You can think of it as just our typical standard deviation that we've worked with in business.1. So recall C is the number of groups in a factor, and J is the number of sample observations on the response variable in group J. J equals 1 to C. So in our example, recall that we had C equal 4 groups, and then N1 equaled N2 equaled N3 equaled N4. They were all equal to 10, which meant that big N, so big N would be equal to the sum, I equal 1 to 10, NJ, J equal 1 to 10. So this would be equal to 40. So our total sample size was 40 because we had 4 groups, and all 4 groups had a sample size of 10. So Xij is just the value of the response for the ith observation in group J. So there's a lot of notation here, but we're really going through this for completeness so we can understand what's going on. We're ultimately going to be calculating these things in Excel. We're not going to be doing this by hand. So X bar bar is just the grand mean, the overall mean. So we can use it as this big complicated formula. You could also think of it as just our basic mean formula, which is just the sum of all the data divided by the number of data points. And so to give an example, if we had 3 groups, an SST is just the total variation. So from the first observation in the first group up minus the overall mean, all the way up to the last observation in the first group. This would be the first observation in the third group, and this would be the last observation in the third group. So we're just taking all of the sum of squares, and that is our total variation. Now variation among groups or between groups, so this is just the average for each group minus the overall average. And we just multiply by how many observations are in that group. So notice that this is summed over J equals 1 to C. So in our example, we would take the overall average across our 40 data points, subtract off the average of Europe, average of Asia, North America, and South America. And so this would be equal to 4. So we would have 4 differences that we would be summing up. So again, C is the number of groups, NJ is the number of observations in that group. So X bar J is just the average from that group. So that could be the average of Asia, average of North America, average of South America, and so on. X bar bar is still just the overall average of all 40 data points. And so we can see how this would be written if we had 3 groups in our factor. And then finally, within group variation, so this is the random variation across or within each of the groups. And so it is every observation, individual observation, subtracting the mean of that group. So that would be the first city in North America minus the average of North America. Taking the second city in North America, subtracting the average of all of North America. So we'll need to do this for every observation in every group. So every observation for every group. So again, C being the number of groups, and J is the number of observation in each group. X bar J, that's just the average for each group, so the average of Asia, North America. Xij is just any individual observation, so the ith observation in group J. And again, we can represent this whenever C is just equal to 3 with this formula. So that's what we're doing. That's what's going on behind the scenes. It's important that we see this and get an idea as to what's happening. But like I said, we're going to be doing this in Excel. We're not going to be doing these calculations by hand.